striving to conceive of God in a universe which is subject to equations, in a physical world of chemical bonds, whose continuous action has as a final result universal balance and harmony, we are led to the conclusion that God is the cause of the substance and essence of the existence and function of all things. From the depths of the cause, the laws emerge. The laws are proven by the operations of numbers and their equations on the totality of the matter in the cosmos. The laws are the platform on which stands the structure of the universe, which reflects the substance of God. The substance of God is visible to man and partially measurable. His essence is infinite, unknowable, and inconceivable. Man, from the observatory of knowledge, can calculate, study, and demonstrate facts which concern the substance of God, and this belongs to the sciences. The essence of God is conceived solely through internal insight, philosophical thought, and the bond between the human soul and the soul of the world, to which it is subordinate and to which it belongs. That the universe exists is confirmed by science. Why it exists belongs exclusively in the domain of insight and wisdom. A beginning of creation could never have existed. Creation is the eternal recycling of the totality of matter in the universe, which brings to completion its evolution and devolution. Evolution is the progression of the matter in the universe from the spiritual world, which expresses divinity, to its inner being in all things, through which the universe acts, moves, and exists. Devolution is the progression from the inner being of the universe outwards, towards the spiritual world, so that matter may return to its initial dynamic state. Both the evolution and devolution of the universe function on the basis of the totality of laws. Laws which are self-existent as a result of the reason for being of the substance of God, and on which depends the existence and function of all things.
The ancient Greeks believed that the nature of infinity expressed the nature of God. Anaximander, the student of Thales, informs us about the infinite and indefinite nature, both in quantity and in kind. Matter, continues Anaximander, moves of its own accord, and this constitutes a confirmation that the universe itself is immortal and indestructible.
Objections to the interpretation of the theory of relativity by many scientists of our time, which they supported with Hubble's discovery that the universe is continually expanding, are many and do not involve only philosophical and theosophical views, but scientific views as well. In the theory of relativity, the inner tendency of the universe to expand is called the cosmological constant.
Στην κοσμολογική σταθερά, ο Αϊνστάιν, εξ όσων έχω διαβάσει, υπονοούσε...
In Einstein's cosmological constant, Einstein, from all that I have read, suggested an anti-gravitational force that he expressed in his equations, precisely so that his equations would hold and not collapse. Therefore, Einstein introduces the idea of anti-gravity, which until then had never been discussed. And I would like to ask you to comment on that, when from a logical point of view, we see that anti-gravity is the opposite of gravity, darkness is the opposite of light, right the opposite of left, and so on. In other words, must anti-gravity indeed exist? And that madness that Einstein confessed to, perhaps in the end, it was not madness?
As I told you in my first answer, Einstein had confronted a static universe before Hubble. Aesthetically, he did not want to believe what his equations said. His equations told him to believe what they said from the beginning, that the universe is expanding. Einstein, theoretically if you like, aesthetically if you like, did not accept that conclusion, and he placed that term in his equations, the cosmological constant, to put a brake in some way on the expansion which his equations were telling him existed.
Τη διαστολή που του έλεγαν ότι υπάρχει στο σύμπαν, που του έλεγαν οι εξισώσεις του.
If we accept that space-time continuously expands, and with it expands the total of the galactic systems, does this outward fleeing tendency involve all the matter of the universe, or only the galaxies? For the expansion of the universe to become easily understandable, we must refer to the scientific discoveries about the universe that marked the 20th century. In the year 1924, the American astronomer Edwin Hubble demonstrated that our galaxy is not the only one, and that hundreds of billions of other galaxies exist scattered throughout the cosmos. The planet Earth is located in a galaxy with a diameter of approximately 100,000 light years, which slowly rotates. For one rotation, it requires many hundreds of millions of years. Likewise, in 1929, Hubble astonished the scientific community throughout the world by demonstrating that most galaxies have spectra that displace towards red, and that this displacement was directly proportional to the distance of the galaxy from the observatory on Earth. In short, Hubble demonstrated that the farther the galaxies distance themselves from Earth, the greater their velocity. Of course, this leads us to the view that sometime in the future, at the greatest velocities, they will become incandescent and thereafter dematerialize. The frontiers of the universe, in that critical zone of this dematerialization, cannot be known to us on account of their vertiginous distances, as well as on account of the stellar curtain. Professor Hawking gives us his scientific view on the frontiers of the universe.
By far the most elegant is what Jim Hartle and I called the no-boundary proposal. This can be paraphrased as, the boundary condition of the universe is that it has no boundary. In other words, space and imaginary time together are curved back on themselves to form a closed surface, like the surface of the Earth, but with more dimensions. The surface of the Earth has no boundary. There are no reliable reports of someone falling over the edge of the world. The no-boundary condition and the other theories are just proposals for the boundary conditions of the universe. To test them, we have to calculate what predictions they make and compare them with the new observations that are coming in.